Hello friends, welcome to week 6 of our course on climate change and disaster risk management. In the last unit, we explored how first aid, sanitation, shelter and basic necessities like food and water form the backbone of any emergency relief operation. But as we know, disasters today are becoming more frequent and complex. So, simply reacting is no longer enough. We must respond smarter and faster. That's why in Unit 6.3, we'll move a step further into the exciting world of technology-enabled disaster response. Our focus is on 3 powerful tools that are transforming the way India handles emergencies. First, drones. Second, IoT or Internet of Things based sensors. And third, robotics. India faces frequent floods, earthquakes, cyclones, and landslides. Traditional response systems often struggle to reach everyone quickly, especially in remote or dangerous areas. But today, technology is bridging that particular gap. From the skies above us to the sensors beneath the ground and even robots that walk through the debris, new tools are saving lives faster than ever before. So, let's dive in and discover how these smart tools are helping our responders act quicker, safer, and more efficiently when every second counts. Let's begin with drones, often called our eyes in the sky. Drones or unmanned aerial vehicles, UAVs, have become the first responders in the air. They can fly over the flooded villages, they can fly over collapsed buildings or hilly terrains that are otherwise very hard to reach. Think of how useful that can be when normal routes are blocked and time is running out. First, search and rescue. During disasters like earthquakes, landslides, drones equipped with thermal cameras can detect the body heat, which can further help the rescuers find the people trapped under the debris. For example, during the 2025 Myanmar earthquake, Indian teams used tiny nano drones with thermal sensors to locate survivors in damaged areas. Second, damage assessment. Once the immediate rescue begins, drones continue to help. Drones can map affected regions in just minutes. In the 2024 Wayanad floods in Kerala, drones captured the aerial images to assess the damage and identify the safe routes for the rescue teams. Work that used to take days was completed in hours. Third, delivering the medical supplies. In places where roads are cut off, drones deliver vaccines, medicines, and blood packets. A project in Telangana reduced delivery times from 4 hours to just 30 minutes, a breakthrough that can mean the difference between life and death. In short, drones give the responders speed, visibility, and accuracy, 3 things that matter the most during any kind of crisis. While drones work above the ground, IoT sensors quietly monitor what's happening around us. Rivers rising, air changing, ground shaking, and they send the alerts before the disaster strikes. In simple words, IoT means connecting devices and sensors through the internet so that they can share real-time data often before anyone even knows a threat is coming. Imagine this. A small sensor near a riverbank detects that water levels are rising faster than usual. Within seconds, it sends an automatic warning to the authorities and nearby residents. That's the power of IoT. After the 2013 flash floods in Uttarakhand, authorities installed smart sensors that measure rainfall, water levels, wind speed, and humidity, and trigger instant flood alerts when danger levels rise. Similarly, Kerala's flood monitoring system now uses IoT devices to issue color-coded warnings green, yellow, orange, and red so communities can take timely action. And the best part? These systems are becoming remarkably accurate, sometimes predicting floods or fires with over 95% reliability. So, while drones respond after a disaster, IoT helps us prepare before it happens. Now, let's shift from the skies and sensors to the ground, where the real danger often lies. In many disasters, the environment is too dangerous for humans. Buildings collapse, fires break out, or toxic materials leak. That's where robots step in, our brave mechanical assistants. Let's have an example of rescue robots. During Operation Brahma in 2025, India used legged robotic mules that could climb over rubble to deliver supplies and locate survivors in earthquake-hit Myanmar. Talking of water rescue robots, in Mumbai, the fire brigade now uses floating robotic buoys to save people from drowning. These machines can carry victims safely back to the shore even in rough waters. There are also borewell rescue robots. In several states, small robots with cameras and mechanical arms are being used to rescue children trapped in deep borewells, performing delicate tasks that humans cannot. Robots extend human capability. They go where humans can't, keeping rescuers safe and boosting the chances of survival. What happens when technologies work together? Now imagine this, a perfectly coordinated response. IoT sensors detect a sudden rise in river levels and send early warnings. Immediately, drones are launched to scan the areas and transmit live visuals to the control rooms. Based on this data, robotic teams are dispatched to rescue the people and clear blocked paths. This is the power of integration when technology works hand in hand, turning separate tools into a connected, intelligent system. Such synergy transforms disaster response from reactive to proactive, saving more lives faster. Let's look at a real example of Kerala's integrated response during the 2024 Wayanad landslides. Early warnings from the IoT sensors gave residents time to evacuate before the slopes gave way. Soon after, drones flew over the area, mapping the damage and locating the survivors. Guided by those visuals, rescue robots carefully entered the unstable zones to search for trapped people. This seamless coordination between humans and technology proved one thing: when science and compassion unite, resilience becomes reality. Let's now talk about the challenges. Of course, it's not all smooth. Technology brings its own set of challenges. Rough terrains, bad weather, weak internet signals, and high costs can limit how widely these tools are used. Training responders and maintaining machines also require time and resources. But the good news is, India is moving in the right direction. With expanding 5G networks, stronger digital infrastructure, and Make in India innovations, these hurdles are slowly but surely being overcome. And what lies ahead looks even more promising. Artificial intelligence, or AI, is now being integrated into the disaster management systems. Soon, drones and robots could make their own decisions, automatically flying to danger zones or analyzing live data without waiting for human command. Government initiatives like the NIDAR Challenge or the National Innovation Challenge for Drone Application and Research and Make in India are encouraging young innovators to create affordable, homegrown disaster technologies. With continued training, collaboration, and innovation, India is steadily moving towards a future where technology and humanity work hand in hand to protect lives. So friends, today we have seen how drones, IoT sensors, and robots are reshaping India's disaster response, turning information into action and action into hope. From the skies above to the ground below, these tools give responders new strength to face any challenge. And as technology continues to evolve, our goal remains simple: to save every possible life and rebuild communities faster and safer. In the next week, we'll turn from machines back to people, exploring the human side of disaster response. Week 7 will take us into health and psychosocial support in disasters, where we'll learn how to care not just for the bodies but also for the minds and hearts after a crisis. Until then, stay curious, stay safe, and remember, Technology is most powerful when it serves humanity. Thank you and see you in the next session.